A familiar material designation does not by itself make an HDPE joint suitable for the job. The real risk appears when the selected fitting meets uncertain ground, restricted access, variable service duty, an unconfirmed pipe interface, or a jointing process that has not been proven in the field. For procurement teams, the decision is therefore not simply PE100 versus PE100RC. It is whether the material, fitting, installation method, service conditions, and evidence form a compatible system. PE100 is an established polyethylene pipe system material designation. PE100RC is commonly considered where enhanced resistance to slow crack growth is a central design concern. Neither designation independently confirms compatibility with a nominated pipe, fitting configuration, pressure class, construction method, or local standard. Those relationships must be established through product and project evidence. Slow crack growth should be treated as a risk topic, not as a marketing phrase. The team needs to identify conditions that may introduce sustained local stress or damage exposure, then confirm that material evidence, design controls, installation procedures, and inspection records address the full risk pathway. Broad terms such as industrial grade, high pressure, or harsh underground environment do not constitute approval criteria. They must be translated into specific conditions, including pressure, temperature, conveyed medium, ground condition, installation method, branch geometry, and required fusion records. A practical review begins with 5 connected factors. First, assess the installation environment. Controlled trenching and handling generally create a clearer evidence path, while difficult ground, restricted access, uncertain handling, repair work, or irregular support conditions require more explicit installation and material documentation. Second, define the service duty. Water, gaseous fuels, mining water, and industrial fluids cannot be reduced to one generic material statement. Pressure, temperature, chemical exposure, abrasive service, and the applicable standards context determine which limits and documents must be checked. Third, verify the system interface. Compare nominal outside diameter, SDR, pipe source, fitting configuration, branch ratio where relevant, and the expected fusion procedure. PE100 or PE100RC wording cannot resolve a dimensional mismatch. The fitting must be assessed as part of the pipe system, including its material interface and the process used to create the joint. Fourth, evaluate jointing control. Electrofusion, but fusion, and branch connections each introduce different control points. For electrofusion, preparation, scraping where required, alignment, clamping, barcode reading, cooling, and traceable records all deserve attention. A sound material selection can be undermined by a poorly controlled interface. Fifth, examine evidence quality. Useful documentation identifies the proposed material, the exact product scope, relevant standard context, and the traceability records accompanying delivery and installation. A broad product claim or incomplete certificate should prompt clarification rather than an assumption of compliance. These factors support 4 decision tiers. Tier 1 applies when the duty is specified, the pipe and fitting schedule are matched, product evidence is part-specific, and the installation process is established. Normal submittal checks can then be completed efficiently. Tier 2 covers a limited uncertainty, such as a new fitting size, alternative geometry, or newly introduced work front. Clarifying documentation and procedure confirmation may be sufficient. Tier 3 applies when several uncertainties connect service conditions, system interface, and installation method. Procurement should pause for coordinated technical review and, where appropriate, representative testing. Tier 4 is reached when a critical condition remains unknown or incompatible. The case should return to the responsible design authority or asset owner. Before an order is released, extract the project duty, pipe schedule, service requirements, installation assumptions, and applicable standards from the approved design documents. Request an exact fitting schedule, verify the PE100 or PE100RC statement against product-specific evidence, assign the decision tier, and confirm the fusion equipment, operator requirements, parameter process, and retain joint record. Where equipment, pipe source, site conditions, geometry, or procedure introduces uncertainty, a trial fusion should be considered before production installation. The strongest procurement decision is the one that connects material evidence to actual operating and installation conditions. PE100 and PE100RC remain useful designations, but project judgment depends on the complete system. Compatible dimensions, defined service duty, controlled jointing, and records that remain traceable through closeout.